All right, we're doing chapter 1, section 4, perimeter and area and coordinate planes, and classifying polygons. All right, what is a polygon? A polygon means many angles, so we should hopefully know what polygons are. I don't know if we know definition-wise, but it's a closed plane figure formed by coplanar segments, which are my sides. So we have hopefully seen a shape. We've all seen a shape. And it just basically means it's closed. That's the most important thing. It's a closed figure whose sides, obviously, they all connect. Okay, so super important for this one, it must be a closed figure. Let me highlight that. It has to be something closed. It cannot be opened in order for me to consider it a polygon. Next thing, each side must intersect exactly two sides, one at each endpoint. Main thing here is at each endpoint. Doesn't necessarily mean it goes through. The only time it can intersect is two sides. So I'm going to show you what that means. If I have a line, let me go ahead and draw a line here. It could only intersect at these 2 points. If, let's say, something goes through it and it's intersecting another side, this cannot happen. It cannot intersect anywhere else other than the 2 endpoints. And when we get to the examples, I'll show you what that means, seeing it visually on a diagram. Next, it says no 2 sides with a common endpoint are collinear. Okay, and again, that's similar to kind of what I explained, but I'll show you in a diagram. And the last thing is each endpoint of a side is a vertex of the polygon. So when you have your 2 sides meet at a specific point, that point is called your vertex. And you'll see that in the problems. It'll say vertices. That means more than one. But all of these things must happen in order for something to be called a polygon. So all must happen. All right, looking at the next slide, it says identify the figures that are not polygons. So let's go ahead and look at the first figure. Is this a polygon? Let's see, is it closed? Yes, are all the endpoints meeting at a vertice? Yes, so this is yes, this is a polygon. And let me go ahead and show you that this is my endpoint, that's also called my vertice, same thing here. And there's no overlapping on my segments. So because they all meet at an endpoint and it is closed, this is a polygon. So going ahead and looking at the next one, is this a polygon? No, why? Good, it's not closed, it's open. Here is my open part. This is no. Okay, no, not closed. Okay, it's left open, so this is not a polygon. All right, looking at C, is this a polygon? No, it's not. God bless you. If I were to draw this line, keep in mind it has to meet at the endpoints, right here and right here. Is there something crossing in between? Yes. Okay, these points cannot happen. We cannot have that. So because these lines are here, this is no. This is not a polygon. Just visually drawing it again, they could meet at the end, but you can't have stuff intersecting. Okay, so just clarifying that again, you cannot have lines going through lines or sides going through sides. So now looking at D, is this a polygon? Yes, it is. Okay, so this one is a yes. Again, there's nothing overlapping here, so it's yes. And then looking at E, is this a polygon? No. There's a lot that's not going on here. It's not closed. There's no endpoints. It's not a polygon. All right, convex polygons. No line that contains the side of a polygon contains a point in the interior of the polygon. I know that's a lot of words. What does that mean? If something is convex, that means if I were to take my pencil, ruler, or whatever, and continue drawing this line right here, let me get a blue one. If I were to continue drawing this line, using all of the sides, so just looking at it, do any of those sides go on the interior of my polygon? If it's drawn correctly. So let me highlight it. Here's the interior of my polygon. Do any of those lines go on the inside? Does it cross on the inside anywhere? No, then this is convex. Okay, so something we need to know, none of the lines go in the interior. Okay, so again, looking at the example, here's my interior. If I were to continue drawing these lines, which they have for you, nothing goes on the interior. Same thing with the last one over here. If I were to continue drawing these lines, it does not go inside my interior. So again, this is convex. Okay, this is convex, does not go inside the interior. Now looking at the next one, concave. I like to think of it, it has the word cave. Don't get caved in or cave in. So now if I'm looking at this one and I were to continue drawing these lines, if you're looking at that one line that I just drew here, I'll draw it in red. If you're looking at this one line, it does cave in. It does go on the inside of my polygon. So here's my polygon. If you're looking at it, that red line did go through the inside of my polygon. So think of it as caving in, okay? Concave does cave in, okay? Convex does not. So that's a way to know both the difference. Concave goes in, convex does not. If you want to write cave in, just so we know what caves in, it goes inside. You can write that just to remember. But yes, it does go on the interior. All right, looking at classifying polygons, we should know some of these, okay? I'm not going to say you have to spell it perfectly. However, spelling for this should matter. The only thing I don't want to see is when you are spelling something, do not try and combine two names together, okay? So let me see if I can find an example or think of an example that was given. For example, hexagon and heptagon. Some people get those two mixed up or may get them mixed up. They may put hexpentagon, okay? So they may add an X somewhere in there to make it seem like I'm not sure if it's hexagon, I'm not sure if it's heptagon, but you have to choose one. So let's just go through these. We should know some of these. Looking at the first one, 3 sides, we know it's a triangle. We should hopefully we know it's a triangle. 4 sides, please do not put a box, don't put a square. It is a quadrilateral. Okay, 4 sides is a quadrilateral. Think of a quad, 4, quadrilateral, 4. We have pentagon, which is that government building. It's actually in the shape of a pentagon. It has 5 sides. Hexagon, think of the word 6. Okay. S-I-X, they both have an X in it, so think of 6 sides. Heptagon, you just have to know how to spell heptagon. I know that heptagon is something with 7 sides. Octagon, that one should be easy. An octopus has 8 tentacles, so 8 sides is an octagon. A 9-sided shape is a nonagon, not a ninagon. It's a nonagon. It has that O. 10 is a decagon and 12 is a dodecagon. Okay, don't get those two mixed up. 10 has less letters, decagon. 12 has more letters, add 2 more, dodecagon. Anything after that is whatever the number is gone. So giving you an example. If I have 15 sides, it is called a 15gon. If I have 28 sides, it's called a 28gon. Okay, use what's given here so we know. 11 is an 11gon. Okay, 11 is an 11gon. I understand that there may be some names out there on the internet. Just use the ones that are on here, please. Yeah, if it has more than 12 sides, just, if I had 100 sides, 100gon. Okay, so just use that format, please. There are some names for certain ones out there. Just use the ones on here. All right, let's go ahead and do these together. It says, tell whether the figure is a polygon and whether it is concave or convex. So looking at A, is this a polygon, yes or no? This one tricked some people. Yes or no? No. No. This is not a polygon. Why is it not a polygon? Because of this right here, this little intersection. All right, looking at B, is this a polygon? Yes. All we have to state, is it concave or convex? Convex. Good, convex. Again, if you were to draw those lines, it does not cave in. So it's convex. All right, looking at C, this is a curved line. Keep in mind, polygons have segments. So is this a polygon? No. Okay, this is a no. I cannot have curved line. This curved line here is an arc. I cannot have an arc. It has to be straight lines. I know it's a little blurry with the pixelation, but it's a curved line. All right, and looking at D, is this a polygon? Yes, and is it concave or convex? Good, concave. Again, just drawing one line, we see that it does cave in. All right, questions on these 4. Okay, let's go ahead and go to the next one. This one says classify the polygon by the number of sides. Tell whether the polygon is concave or convex. So looking at A, counting my sides, 1, 2, 3, 4, 5, 6 sides. What would I classify this polygon as? What would I call it? Hexagon. And is this hexagon concave or convex? Good, convex. Looking at B, what would this shape be called? Good, quadrilateral. Concave or convex? Good. And looking at the last one, how many sides are there? Okay, good. You got to count carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is this called? A dodecagon. Okay, don't forget that do. Concave or convex? Good. Concave. It caves in if I were to draw a line. It caves in right here or obviously other places, but this is concave. As long as one does it, it's concave. All right, looking at the next slide, it says finding perimeter and area in the coordinate plane. So we have to know formulas. Are these formulas going to be given to us? No. Okay, you guys have hopefully been covering this since middle school, maybe even before that, but we should know these. A triangle area is half times base times height, or some people like to write it as base times height divided by 2. Okay? For a square is your side squared. Keep in mind a side. These are my congruent marks. Because it has one tick on each side, that means all these sides are the same. So if this was 3, this was 3, this was 3, this was 3. All you're doing is squaring it. For my rectangle, the formula is, yes, length times width. Some people put base times height. That's fine. Okay, length, width, base, height, same thing. Again, here are my little tick marks. Because this has 2 tick marks, these are the same, but they're different from the ones that have 1 tick mark. So as we get further along, you guys will see a lot of those. Keep in mind, think of it as a matching game. If it's matching, it's the same. If it's not matching, it's not the same, okay? So formulas, like I said, are not going to be given to you. So you just have to really know the basics, the ones right here. If we give you anything else, we'll tell you you have to know it. Oh, perimeter. Let me just go over perimeter. We all should hopefully know perimeter. What do we have to do to find perimeter? Add all the sides. Okay, yes, you could remember the formulas, the rules for it. Just add all the sides. Okay, make sure you could add them. All right, looking at this example, it says find the perimeter of triangle ABC with the vertices A, B, and C. Okay, let me just go over this little symbol right here. Okay, this is, yes, a triangle. Eventually, you are going to start naming triangles. If you do not use the triangle symbol, I'm going to say you're naming a plane or 3 points. Please make sure you use that triangle symbol to name a triangle. Okay, so just clarifying that. And here's that word vertices. That means more than one corner of my shape. So go ahead and graph it. Keep in mind, we are trying to find perimeter. Graphing our points, I have -2, 3 right here. Here's my A. B is +3, -3. Here's my B. Connecting my points. Again, I'm making a shape. And then I have -2, -3, and this is my C. And again, connecting it to make a triangle. So if you did not make a triangle, it says triangle ABC. Please make sure it looks somewhat like a triangle. So now all I have to do is find my perimeter. How do I find my perimeter? Like we said, we have to add all the sides. So looking at this, I have a total of 3 sides here. So adding my side, let me go ahead and add them. I have A to C. All I really have to do is just count. I don't necessarily have to use the absolute value of the difference, which we can, but we can also just save time. 1, 2, 3, 4, 5, 6. I have 6 on this side. And then C to B, I have 1, 2, 3, 4, 5. And then can I just count from A to B? Can I count just like that? Will it give me an accurate answer? No, absolutely not. So please do not do that. You cannot just count. What do I have to do to find the distance from point A to B? What do I have to use? I have to use the distance formula. So if you already forgot the distance formula from your first quiz, you have to memorize that formula. It's not going to be given to you. So looking at it, distance formula, I'm going to have the square root. I'm just going to go ahead and write it down. x1 minus x2 squared plus y1 minus y2 squared. Going ahead and plugging in. Keep in mind, I'm using A to B. That's the distance I'm trying to find. So do not use point C. It's just A to B, just those 2 points. So plugging in what I have, I'm going to use -2 minus 3 keep in mind it's squared plus 3 minus negative 3, and again it's squared. Don't forget that square root. Changing this to a plus symbol, I'm going to get negative 5 squared plus 6 squared. Don't forget that square root. Negative 5 squared times negative 5 times negative 5, that's negative 5 squared. I'm going to get a positive 25. Plus 6 times 6 is 36. Don't forget to square root it. Adding these two together, I'm going to get 61, the square root of 61. Can I simplify the square root of 61? No, I cannot. So that will be my answer for this side, the square root of 61. Now all I have to do is add everything together. I have perimeter is going to equal 6 plus 5 plus the square root of 61. Combining what I can, 6 and 5 is going to give me 11 plus the square root of 61. Can I add 11 in the square root of 61? No, I cannot. So I'm going to leave it like this. And that's telling me that this is my answer. Okay, do we have any questions on how to find perimeter? Again, if it's a diagonal line, you have to use the distance formula. If you were to just count and give me a number, it would be wrong. So please do not do that. All right, let's go ahead and look at the next question. It says find the area of triangle DEF with these vertices. So go ahead and graph them. You're going to get 1, 3. That's DE is 4, negative 3. Connecting my dots. And then F is negative 4, negative 3. It's asking me for area, and I have a triangle. So now I know I'm going to use the formula area equals. I'm going to do base times height divided by 2. Let me go ahead and find my base. Your base has to be that flat side. Okay, counting 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to have 8 times, how would I get my height? Does anybody know? How would I get my height? Yeah.
You count the units up from the point
Good.
of the base to the point of the height.
Perfect. You have to count your units from the point of the base to the point of the peak of your triangle. So keep in mind, a lot of students will forget this. It has to be that 90-degree angle. So it has to be right here. The point of my peak to my base, 1, 2, 3, 4, 5, 6. It has to be that 90-degree angle that's there. So that's going to be 6. And then all you have to do now is multiply them and divide it by 2. So multiplying it, I'm going to get 48 divided by 2. My answer is going to be 24. Please keep in mind, if anything's ever asking for area, your answer is in square units, okay? So my answer would be 24 units, because they didn't give me anything, squared. Questions, comments, concerns? Okay.